Hard to believe we already made it to the last month of 2023, but here we are, and December can certainly be a month full of burr in Colorado. We get big snows and our first really strong cold outbreaks. Denver and the Eastern Plains get some paralyzing storms. Witness the Christmas Eve blizzard back in 1982. Now, the average temperature is right around freezing for the month. So the warmest was in December 1933 when we were about 44 degrees for the average temperature, and the coldest was 17.4 in December 1983. The average high on the first of the month is 47 and it's 44 by the 31st, and the lows go 21 down to 18 by the end of the month. The snowiest December and the snowiest month for any month in Denver history was back in 1913 with a massive storm that dropped 4 feet of snow early in the month. We finished with 57.4 inches of snow. There was no precipitation at all back in 1881. The hottest temperature ever, 1939, 79 degrees, and the coldest 25 below zero, and that was December 22nd, not that long ago, back in 1990. And in 2002, we had a very dry December with just a trace of snow. Here are the top 7 snowy Decembers. 1913, 57.4. 1973 had over 30 inches, and 2006, almost 30 inches of snow. December 1982 with the big Christmas Eve blizzard, 27.1. 1987 saw 21.5. 2007 had over 20. And 1918 had just about 20 inches of snow. Our storm threats: big snows, big chill. Sometimes we get fog and wind coming in ahead of some of those significant winter storms. So what's going to happen this time around? Well, let's start with our drought conditions. Right now, we're still out of drought in Denver, Fort Collins, down to Pueblo and Colorado Springs. But the drought is developing northeast Colorado, and it's now moderate drought across southwestern Colorado. Statewide and across the nation, moderate drought to the south and west, severe drought in the Midwest and the southeast, and moderate drought now across the Pacific Northwest. You may have heard, after 3 winters of cooler than average water conditions, we now have warmer, and that's called El Nino out in the Pacific. And that puts a lot of energy into the atmosphere, and it tends to change how the jet stream flows. We tend to get more of a split jet stream flow and more of a west to east. That is important because that tends to block the colder air up in Canada. We get fewer, not necessarily none, but fewer Arctic outbreaks, and that storm track oftentimes takes heaviest rains and snows south, and so we'll see what happens as far as this year. This is the current 30-day outlook. Equal chances as far as warmer or cooler to the west, warmer across the east, little wetter eastern Colorado, Central Plains, and wetter as we would expect with El Nino across the southeast, drier across the northern plains. 90-day forecast, warmer than average because we're blocking that Arctic air. With the storm track coming through like this, a little cooler than average perhaps for Colorado and down to the south, and wetter than average conditions across that southern section, especially the southeast. Drier farther to the north. We'll see how all of that plays out. You can help us measure how much moisture we get by becoming a member of CoCoRaHS, the Community Collaborative Rain, Hail, and Snow Study. And we have over 20,000 weather watchers worldwide. We'll teach you how to measure rain, hail, and snow. You get a rain gauge, and you can report those conditions every single day and see what other people are getting as far as their rain or snow. If you want to learn more, it's free and it's fun if you're a weather nut. www.CoCoRaHS.org, and you can join the group. Now let's talk a bit about climate change. We've seen a lot of rapid tropical development worldwide. Tropical storms get stronger, faster, and they get wetter. Heat waves and droughts, the shrinking of the snow and ice, record-setting wildfires, that's already beginning again down in Australia where they are close to their summer season. But here's one that's kind of a little bit harder to picture. We can actually, with warmer conditions due to climate change, see changes that can bring local cold waves because of changes in the jet stream. It's called Arctic amplification. As the Arctic gets warmer, the jet stream, which feeds off the temperature contrast north and south, weakens. And when it weakens and slows a little bit, it can become more wavy. And so the analogy would be, think of a fast-moving mountain stream versus a slow meandering river. And every once in a while, that can mean a big cold outbreak will drop way farther south. Of course, it's probably getting warmer in other northern areas, but that's what happened a few winters ago in Texas when they had that bitter cold outbreak. And even though it seems counterintuitive, yes, with global warming, you can actually get regional cold outbreaks that develop. Now, we've been a little bit cooler in the western part of the United States for the whole summer and into the fall, but most of the world's been very hot so far in 2023. One of the hottest, if not the hottest year on record. Locally, a little bit of cooler weather, but not global climate. The world is warming up. That warming is due to the increase in carbon dioxide in the atmosphere, and that carbon dioxide is increasing from burning fossil fuels. We add 38 billion tons of carbon to the atmosphere every single year. You can see a few little dips here when the economy's slowed. But basically, on average, about 100 million tons every single day goes into the atmosphere. And people have said to me, well, how do you know it's not from something else like volcanoes? Well, we can measure the isotope or the flavor of the carbon. We know that it comes from fossil fuel sources. That signature, that chemical signature, comes from burning coal, oil, and natural or fossil gas. And the warming that we've seen, we started about 280 parts per million of CO2 in the atmosphere at the beginning of the Industrial Revolution, and we are now in 2023 over 420 parts per million. That heat that's trapped because it gets redirected from going out into space has resulted in about 2.5-degree rise in temperature globally since the beginning of the Industrial Revolution. We're now at about 420 and change. These are the different reporting stations: Barrow, Mauna Loa, American Samoa, the South Pole. They go up and down with the seasons because during the growing season, plants absorb more carbon dioxide, but during the winter season, we have more carbon dioxide back released into the atmosphere as the plants decay. So when you take the average, which is what I show every single day on TV, that's what we're talking about. And the result, 10 hottest years on record globally have all occurred since 2010. 2023 may be well on track to be the hottest year on record. One more month to go. Departures from the early industrial era, we don't get very many years at all anymore with colder than average conditions. That trend is clearly up, and it matches what we're seeing with the increase in carbon in the atmosphere. So here's how that works. CO2 changes the global heat balance. Sunlight comes in, that's visible light. Shortwave radiation, we call that. Warms the planet. Infrared or longer wave radiation radiates back out into space. And if you change that balance by trapping some of the heat, the planet gets warmer. And that CO2 will linger in the atmosphere for centuries. We call it the residence time. So let's just do an example here. The Earth is 4.6 billion years old. Let's scale that down to 46 years. 8 months ago, dinosaurs lived. 4 hours ago, human beings began to exist. 1 minute ago, we had the Industrial Revolution begin. And in that minute, we have added half again, more carbon into the atmosphere. It has gone up and down in the past because of volcanoes and some other changes in the history of the Earth. We're talking over the course of billions of years, but it's happening so fast, that's the problem. Species may not be able to adapt. So how do we put it back in the ground? You hear about carbon sequestration. Well, let's do some numbers here. 100 million tons per day are current global emissions. The target, not even yet scientifically or economically feasible, would be if we could contain that again, put it back in the ground at $100 a ton. That would be a target price, and we're not even close to reaching that. That would cost us $10 billion a day just to stay even with what we're putting into the atmosphere each day. Or if you want to add that up, that would be $3.65 trillion per year just to remove what we're putting in there every single year. It's better just not put it in there in the first place. Putting that carbon back in the ground is just not going to work very well. And because of that, if we can reduce the amount that we are burning and putting into the atmosphere, it's all the better for future generations. So without strong reasons to cut back on carbon pollution into the atmosphere, we see the warming for the future generations, including my grandchildren. But if we make significant cuts and switch over to renewable energy, we can still stop making it worse and in fact make the world a better place in the future. It's never too late to stop making things worse. And we're helping out with lower carbon energies available now. A lot of wind power going in the central United States. A lot of solar, some in Colorado, a lot down in the sunnier regions down to the south and to the west. So we can still fix this. If you'd like to learn more, here's my book. It's called The World's Littlest Book on Climate. Use that QR code for a free download. 10 facts in 10 minutes about carbon dioxide, the warming of the planet, and ideas of what we can do to fix the problem. Have a great December. Thanks for watching.